In this example, we're asked to rationalize a denominator. When we rationalize a denominator, what we're doing is eliminating a radical from the denominator. And here's the process. The first thing is we've got to notice what kind of radical. In this one, it happens to be a square root. So I know that to eliminate a square root, I need a square. Now this one is, we've got to be really careful with because we have a sum of in this case, the sum of two square roots. But even if it was a sum where one of them wasn't a square root, we can't just multiply this by the square root of x and the square root of s to get rid of those radicals. Try that and you'd see that we still have some radicals in there. So that's not going to work. What we need to do instead is multiply by the conjugate pair. Let me explain what a conjugate is and why multiplying by the conjugate works. If I have a plus b, then its conjugate is going to be a minus b. And what's so special about a conjugate? Well, when I multiply two conjugates, I get what we call the difference of two squares, because if I FOILed this, I'd get a squared, and then I'd get, by using FOIL, plus ab minus ab, right? And do you see that those are going to cancel each other out? Minus b squared. This ab minus ab cancels out. The two middle terms always cancel out, and we're left with this a squared minus b squared. So if I want to rationalize this denominator where the denominator is a sum, I'm going to multiply by the conjugate so that I can get this difference of two squares. So here's what it would look like. We have our square root of x over the square root of x plus the square root of s. And I'm going to multiply that by 1. The 1, why am I multiplying by 1? Because 1 is a multiplicative identity, which means that when I multiply by 1, I don't change the value of the expression. And I'm going to use the 1 in the form of the square root of x minus the square root of s over the square root of x minus the square root of s. Do you see that that's really just a big 1? So I'm not changing the value of the expression. But why did I choose this form? Because when I multiply the denominator, square root of x plus square root of s times itself, I'm going to get the square root of x squared, which is just x, minus the square root of s squared. Or in other words, in the denominator, I would get x minus s. Go ahead and FOIL it if you need to, like I did up here at the top, to prove to yourself that, yeah, that does end up working every time. And then in the numerator, I'm going to distribute this square root of x to the square root of x and to the square root of s. So square root of x times the square root of x minus the square root of x times the square root of s. So the square root of x times the square root of x is just x, and then we have minus the square root of x s. And that's it. That's our rationalized denominator. Would you like to see another example? Here's another example. Oh, not that one. Sorry. I didn't get these in order. I know I have one in here. Let me find it. Sorry. Another example of rationalizing the denominator. You know, I'll have to do that in another video, so sorry about that mislead. But watch for other videos on rationalizing denominators if you need a little more help with that.